All right, so we are Team 1. Our project is the RC car with mechano wheels and the robot arm with the grabber. Our team members are Natasha, our project manager, Omar, the coder, James, our 3D project designer, and I am the electronics manager. Our whole goal was to construct this car based off a pre-made plan of a robotic car that could translate in all 4 directions and have crab motion thanks to mechano wheels, as well as a grabber, because sometimes you just don't want to get up and get something. We realized it wasn't going to have a huge ability to pick things up, but it would still be fun to be able to send it out to the kitchen and bring yourself over. So we took an existing plan and modified it some to be able to make it more workable within the setting that we were planning and working in.
And this is just a brief progress of what we did. So this was weeks 1 to week 6. As you can see on the right, it has all the team members who contributed to each task. And then at the end, because we had some time restraints, we had an expected plan to do the testing, alteration, and finalizing, which we didn't manage to get to. And that's the part in red there. Okay. So for the 3D printing, I would say it was an overall success. We successfully printed all the parts needed for the arms and the wheels. And as you can see in the bottom right photo, we managed to assemble all the wheels. But the bottom left photo shows the parts for the arm that were unassembled. The main issue that we encountered with this and why we weren't able to assemble the arm was calibration and printer errors. We found that our stock bed for our printer was actually warped, and this was kind of messing up our prints. And we thought to upgrade to a glass bed, but we ran into more issues there with adhesion, and the prints just wouldn't stick. We tried a couple different solutions like glue or like hairspray, but we were still having little success with print sticking. And what's more is that we also had a clogged nozzle, but that was not a huge issue because the printer came with spares and we just replaced that pretty easily. We did manage to finish all the arm parts within a good time, but we were not able to print the chassis because that was going to be the largest print out of all the stuff we printed here. And lastly, there were very minor delays with time that was definitely easily recoverable because these misprints happened with smaller prints that were like 10 to 30 minutes long, as opposed to, let's say, the 11-hour prints, because that would have delayed us a lot more. Is James here? Okay, I'll do the intro. So he designed this cab over engine style truck, and he did that in SolidWorks because, CAD, sorry, because he had the most experience with that. We wanted to make the chassis as original as we could. We didn't just want to completely copy the model that we were going off of. We accounted for space. The cargo accounts for the space required for the all the electronic components and the circuits and circuit boards. And we came up with this design that would fit the wheels that we had, and also we would place the grabber arm on the cargo. And this is the frame that was designed as well for optimal support of the cargo and the weight of everything that would have been inside.
So electronically, how this whole thing works is it runs off of a 12-volt battery to power the Arduino, which steps down to 5 and 3.5 volts to supply a variety of the subcomponents and subassemblies. You send a command via Bluetooth in the app. The HC05 Bluetooth receives that signal. It's a Bluetooth chip that sends the message to the Arduino via a 2-pin 3.3 volt serial logic communication. The Arduino then executes the code and sends voltage, a 3.5 volt higher low to control wheel direction or stepper motor direction and a pulse width modulated square wave out to our stepper motor driver circuits to tell each wheel what direction to, or tell each motor sort of what direction to step in and how large of a step it should be taking. And that effectively controls the motion of our vehicle, allowing it to move forward, backward, translate side to side, and even crab along at like those kind of cool 45-degree angles. The whole principle it runs off of is the Arduino Shield, where you're taking a custom printed board that plugs directly into the mother Arduino Mega board and kind of almost acts like a motherboard in a computer, where it takes all of these different parts and connects them together to allow them to communicate with one thing in particular, in this case, the Arduino. But unfortunately, due to time constraints and an excessive amount of research we had to do to figure out a number of the parts that were going to be required, we just simply didn't have the time to get into final assembly, and we're kind of stuck with doing component level testing.
What's going on, you guys? So I am the one that is in charge of the coding for this project. And I mean, for the most part, the coding wasn't too troublesome overall. I would actually say, things kind of just came along together when we, connected pieces and put the puzzle together. So, majority of the time when I was doing the coding, I kind of realized like, if I wanted to make all this stuff work, right, the two main things that I wanted to put together was the Bluetooth connectivity and communicating with the server, because basically without those two things, right, you can't have a functional robot at all. That even includes moving the robot. It even includes using the arm of it, essentially pretty much the whole thing. So I did not get to complete the whole coding process itself. I just got to only do like the Python part of it. And then, if you actually look on the side here, it's like an example of me trying to get the Bluetooth and one of the servos. So one of the servo, basically server, is short for what it is. And, it's just supposed to pertain, like if I wanted to move forward with the robot, right? So the move forward function, I had to essentially code the Bluetooth and the servo together so that they can communicate to provide full functionality of it. And we have to repeat that process for every function of the robot. So that's for the arm, that's for moving in, that's for moving backwards with it. So essentially everything. So I did not get to, complete all that because there was trial and error in it. A lot of consideration and a lot of research had to go into the whole coding process itself. And, who knows how much longer it could have took to get to finish the coding. Excuse me. And then, so yeah, I'm ready. So application design, unfortunately, was more troublesome than the coding process itself. It's very surprising to say. It's just trying to use the MIT App Inventor design layout was just, for some reason, I found it more difficult than I really pretended it to be. Because, some things that I was just running into when I was using this application is, trying to import some pictures to make the design layout friendly user. And, if you just look at the picture application itself, I wanted to, like, of course, move those buttons to like the middle or like to the side or like to the other side. But like, just for some reason, I just could not manage to find a way how to get the application design to, how I'd want it to be. So, I mean, in the end, I did not get to meet the standards for what I wanted to set on the project. And, the application pretty much really remained unchanged, during the last time I tried to demo the application design. So.
So overall, the 3D printing was actually very successful, and we got a majority of the ARM portions printed, and we got all of the Meccano wheels printed and assembled. Unfortunately, we just weren't able to get to printing out the chassis due to the technical hiccups that we ran into with the printing, because it was such a big print. The current version of the model has been able to undergo stress simulations, and James and I coordinated with the size of the Arduino Mega to make sure that all the parts would be able to fit into it. As far as coding goes, like Omar said, there were difficulties, but he got a pretty serious start on it and did have some workable code there, which was able to execute and would have been able to actuate a servo. And as I'd mentioned, due to time constraints and a very excessive research period, the circuitry sort of never got past component level testing.
So overall, we felt pretty optimistic about this project, like we chose it with the direct intentions that we know, like this is going to be a lot. And, we know that you didn't require us, to go out and do something crazy. We, chose it upon ourselves to, see what we can make ourselves out of, polish up on a few attributes and skills and, see like how far, we can get to this project overall. So, I mean, I'm not entirely, just convinced about not finishing the project, because I mean, at the end of the day, like we really gave it all that we got. We communicated as a team. We helped each other as much as we honestly could. And, we had respect for each other, whenever something popped up. And, we do want to intend to finish and complete the project, even though the quarter is going to end and whatnot, because we know like how much of a good accomplishment and achievement this could be for us. And I mean, overall, we took this as a good learning curve for all of us. It just comes to show like what can actually happen in the real world when you go to your actual job, when you work together as a team and you combust ideas and, see what actually gets to happen in the real world. So
And thank you guys. I just want to say this was